we want to find out if this given figure is a rectangle. Now stop and think about what you know about rectangles. They've got 4 right angles. Also, it's got 4 sides. And there's all sorts of other things that we know. We also know that you have 2 sets of parallel sides. Okay, and if we're going to say that this is a rectangle, we need to go and prove what we can see. And I think it's easy enough to go and see that these have 4 sides, and that's okay. Really, we need to know that AC is the same length as BD, and we also need to know that AB is the same length as CD, and we can have a shortcut for that, but we also need to know that they are absolutely parallel. Um, if you have the graph right here, the easiest way to find the slope is literally to count up and over from one point to another. And we're going to keep track of it. I'm just going to say slope right here. And so whenever I say AB, that means from A to B, and we'll find the slope of that line segment. And when I say CD, we'll go from C to D and know the slope of the line segment. Now, these are ordered pairs, you know. This is a point and that's a point, A and B. So we can always go back and use our algebraic equation of y minus y over x minus x and compare the numbers that way. But when we have the graph, if it's not in awkward situations, we can do the following. A to B, let's see, I would count up 1, 2, 3, 4, so my rise is 4. And then I can go over to where B is, and that would be 1, 2, 3, 4. So that'd be 4 as well. So my slope is 1. If these 2 sides, AB and CD, are parallel, they have to have the same slope. So let's count up from C to D. 1, 2, 3, 4. So my rise is 4, and my slope is 1, 2, 3, 4. My run is 4, so that gives me a slope of 1 also. So AB and CD, they are parallel. Well, that's great. Let's go through and let's actually check AC and BD. A to C, let's see, you go 1, 2 down and 2 to the right. So it would be a negative 2 over 2, which is a negative 1 slope. And let's try the same with B to D. Down 2, so that'd be a negative 2 to the right. So that's also a positive 2. So my slope here is the same as AC's, so they are parallel as well. So we've got 2 sets of parallel sides. The next thing that we need to check is does this form a right angle right here? Well, AC has a slope of negative 1, and AB has a slope of positive 1. They are actually the reciprocal of each other, the opposite reciprocal. So yes, this gives me a right angle, and if we go and we check all the other sides, just using the slopes that we have, we'd find out that we have 4 right angles, we have 2 sets of parallel sides, and then what about the congruency of the length? Well, quite frankly, if you're using the counting method 4, 4, you know, we go up 4 and to the right 4, that should tell you that, quite frankly, CD has the same length because we went up 4 and to the right 4. So if these fractions are exactly the same, you'd say, yeah, we're good. The lengths are fine. So I would say, yes, this figure is a rectangle, and that's how we've proved it. You can't just trust your eyes. You cannot just trust your eyes with coordinate geometry. You have to prove everything. So that's an example to start us off with. Sometimes, though, they're going to give you just the vertices of the quadrilateral, and they'll be asking you, is it a square, a rectangle, etc., and they give you no graph. So we need to take a look at that, and before we start, let's take a look about what we know about squares. Quite frankly, we know a square has 4 sides. We know all 4 sides should be the same length. It should have 4 90-degree angles, and it should have 2 sets of parallel sides. That's a square. So we'll go ahead and put that there. And the cool thing is as soon as we can prove that one of these things does not exist, we can say it's not a square. Like if we can prove that they don't have 4 right angles, we know it's not a square. Now, what you need to do here is understand that what you would do is you'd choose 2 points. So like here's AB, okay, and we'll have our information there. Then you would choose BC, and we'll get our information from point B to point C. We also have CD, and we'll get our information there. And then you kind of come back around full circle, and eventually you get D to A. That's how it would look like if I drew like a mock square real quick. Well, not a square, not a rectangle, but a square. You'd have A sitting right here, possibly. You'd have B sitting right here. C would be right here, and D would be right here. So when I'm saying, hey, give me the information about AB, it's this side of AB. BC would be corresponding to this side, BC. CD would be right here. And then you still have to connect for that fourth side, and that would be the D to A, and that's why we have DA right there. So how about I just go ahead and put this little sketch off to the side, and we might be able to use it to keep track of a few things. If I can find slope, I would be able to test if the sides are parallel, and then later I'd be able to come back to see whether or not the sides are at right angles to each other, because it would be the perpendicular line test using the slopes. So that would be very, very useful right there. AB is using -3,6 and 3,7, so let's just go ahead and use the algebraic equation to find the slope. So there's our formula. Let's plug in our values. So I know going from point A to point B, the slope of that side of the square, if it's a square, is 1/6. We'll do the same thing with BC and go from there. Actually, you know what? We might be able to save some time. If AB has a slope of 1/6, then DC needs to have a slope of 1/6 as well. So let's just go down to DC, which would be the same as CD, and let's just go and test that one. Plug in our values. And you see instantly that they have different slopes. So these sides, A, B, and CD, would not be parallel. So we don't even have to go and test about the right angles or anything else like that. The answer is no. This quadrilateral would not be a square because it doesn't have a set of parallel sides. If we saw that these were parallel, we would go and we would find the slope of BC and AD and see if those are the same slope, so we would know those are parallel. If indeed they were parallel to each other, then the next thing we would do is we would be checking for right angles. And I want to show you what would happen here. For instance, we're basically just concerned about this idea of would it be a right angle right here at angle B. Okay, would it be a right angle? I know AB's slope is 1/6. If I found the slope of BC, and that's what we're about to do, if they're perpendicular, they would be opposite reciprocals of each other. And so let's just go find the slope of BC and just to see if it is a right angle or not. So here we've got the formula, and we'll just plug in B and C's information, and we'll go from there. And instantly what you would see would be happening here would be 19/0. And if it was going to be a right angle, it should be -6 over +1. And then that would be this flipped upside down. And since it's positive, this one would need to be negative. And so as a result, we know that indeed it doesn't even have a right angle either right here. And you would just go and check these out. And that's just how you systematically go about this when you don't have a graph.